All right, good morning, everybody, and welcome. Thank you for coming here. I'm always impressed by the people who make the effort to actually get out of bed, even on the last day of a conference, and get in through the rain. It's a good job to all of you. So just before we get started, before I say anything stupid and embarrass myself, I just want to check what people in the room here are already doing in this kind of area. Can you do me a quick hands up if you already use AI to generate code in some way? Yeah, oh man, that's like almost everyone. How many of you are using one of the CLI-based tools like Claude Code or Copilot CLI, something like that? Yeah, right, we're talking maybe about 40% of the room just there. All right, so that's cool. That's very interesting to me because I work on this stuff all the time. My name's Steve. I work at Microsoft and I'm on the GitHub Copilot Coding Agent Runtime team, which obviously needs a shorter name. But that's what we do. I do this all the time. Right, so I'm thinking about AI coding agents, I'm using coding agents to build coding agents, and talking to other people about coding agents. This is a fascinating area for me. It feels like possibly the biggest shift that's happened in the technology industry since I joined it. It definitely is changing the way that I produce code on a normal day-to-day basis. It changes the type of things that I create and what I feel empowered to do. And I'm sure many of you have got different views in the room about this. Like, how many of you think this is all possibly a really terrible mistake? Anyone? Yeah? All right, so maybe only about 10% of people here are willing to admit it, but you know, it is a concern, right? What are we actually getting ourselves into as an industry? What are we going to become? So let's think about this a little bit. Let's think about what we want the software industry to actually be in the first place, or why we got into it. So cast your minds back to some point in the past when you felt that you were really happy in your career as a software developer, when you were working on something that you enjoyed. Like, think of a team that you worked on that you thought was good, a project that you were happy to go in the morning, fire up your computer, get your coffee, and start getting to work on something. Because the industry has brought us all into it, probably for common reasons. You know, I imagine that we've got a lot in common in this room, why we joined this industry. One of the main reasons is probably just we like computers, right? Like most of us, since we were kids, we've just enjoyed doing stuff with computers, and we enjoy using our brains to solve problems with the computer. You know, we'd like the idea that it's complex but deterministic. You know, it's being fair to us. If we can solve the problems, it will work correctly. And we can use our brains to translate our ideas into something that will make a difference in the real world to our users. And this is all great. We've had a good career up until this point by working this way, but it starts to feel like something is shifting it, because up until now, we were the only ones who could create working code, right? We had that unique ability that other people did not. It was like our personal moat that gave us some special economic advantage. But now machines can create code as well, and maybe even non-technical users can use machines to create code. Is this a good idea, or are we running ourselves off a cliff? So let's think about how we got to this point. Right? So it probably started a couple of years ago when a range of tools started to appear that were showing the ways that we can use AI to produce code. All right, so we had things like Cursor and VS Code's agent mode, which were IDE-based tools showing you how you can have this chat with an agent, and as it goes, it's going to start writing code for you. We've also got GitHub Copilot on the web, where you can file an issue, you assign it to the agent, and it's going to make a PR for you. All right, so that's kind of like a first wave of this technology. But then there was also a second wave that came along fairly quickly after. The wave of the CLI-based tools. So Claude Code was the first one that came along and sort of defined this whole product category. And that was rapidly followed by others like Gemini and Codex CLI and Copilot CLI. And I know a good number of you in this room are using those right now. But it's kind of weird, right, that we've decided to go back to this older UI technology when we've clearly got much more modern alternatives. So why are we doing this? It's very strange, right? I think that these CLI-based coding agent tools, they're kind of like, they're often described as like dopamine machines. It's weird, right? Because they're not tied to any particular IDE, they're not tied to a repo, they're not tied to any particular web-based thing. You just pop them open on your computer anywhere, you give it a task, and within 5 to 10 seconds, you've got some sort of progress on that task and you can feel good about it, then you do it again 10 seconds later and another 10 seconds later, and it's weirdly addictive. The teams building these CLI-based tools have been able to iterate really fast. You know, they've been freed up from some of the modern UI concerns and been able to just focus on making the agent really good. And they've rapidly been able to get something much better than you might be used to if you haven't used one of these kinds of tools. But does it make a difference? Well, people will have different opinions about it. And if you believe them, some people will tell you that they're able to produce work a lot faster working in this sort of way. Now, I personally feel that I can relate to that. I definitely feel like I'm able to produce code faster in a wider range of situations than I did before. And I don't think it's just me. Here's some stats from the team that I work on. So this is just 1 week running up until a few days ago. And this is a team of about 7 to 10 people. And, you know, within 1 week, we've merged over 200 PRs on that team. Now, I will admit that about half of these are just trivial, like, you know, add a line to the documentation or whatever. But I would say, realistically, 100 of them are serious features that would have been several days of work in the past, you know, well implemented, full set of tests and all that kind of thing. And so we're getting, what, 100 of these a week out of 10 developers, 10 a week per developer, like 10 non-trivial features per week per developer. That's, you know, a big step forwards compared to what I'm used to in the past. Okay? So let's see what it feels like to do, and let's go on a little journey where we'll have a go at how fast can we create some kind of feature, and then we'll start to think about where this takes us, what kind of new ways of thinking it forces us into, and what kind of problems it might potentially cause for us as well. Because this is not all sunshine and happiness. We might get ourselves into some difficulties with what we're doing here as well. So let's try and anticipate some of that. All right, so let's try and implement a feature. Let's say that you've just joined the Copilot team, and in your first week, you want to add a feature where, well, in your first half an hour, you want to add a feature where it can tell you what models are available to interact with. So we've got Copilot here on the command line, and let's say that we want to run show models. All right, now the problem with that is it doesn't exist as a feature, right? It's an unknown option. So let's implement it ourselves right now. We'll just check that we're in a good, clean state. We are, and we'll pop open Copilot, and we'll try and get to work on that, all right? So our CLI tool comes up, and we can say to it something like, add a -- show models command to CLI that lists available models to process.standardout. Okay, so it's going to get started on thinking about that, and how's it going to do it? Well, I don't know, it's non-deterministic. It's decided that it's going to use the explore subagent in this case. So subagents is a new feature that I'll explain to you in a minute, but that's another agent that's specialized in working out how to do stuff. It's figured out where the CLI entry point is here on index.ts. It sees a pattern that it can follow. It's just telling us that it's going to add -- show models. It's figuring out where to add it. It's spotted that there's some kind of similar thing that it can follow. It's started editing the file just now. Okay, good. Is it done yet? No, it still needs to actually add the implementation of the feature, which it's doing. It's decided to build it, so it's going to check if there's any compile errors. Are there going to be errors? Nope. All right. It's now going to actually run it itself and see whether the feature that it implemented actually works. It says that it does. It's verifying that it's in the help, and I'm just going to stop it at that point. All right, so let's see what we've got now. So let's go and have a look at what changes it's made. All right, so it's added -- show models to the list of options, and it's added a handler for that as well that's going to log some models. Let's just check if it actually works. So if I do Copilot show models now, it does. It produces a list of models. All right, cool. So that was pretty good that we were able to get from nothing to a feature in a minute or so. And you might think, all right, but so what? It's only like a 5-line feature, isn't it? And yes, it is. But the hard part of implementing a feature like that is not really the 5 lines. It's the working out where you're supposed to put them and exactly what constitutes following the correct patterns and that sort of thing. And obviously, if I'd let this go on longer, it would have gone on and written some tests for me and other things like that as well. All right. So that seems like a pretty good starting point for this sort of thing. So hopefully it doesn't seem ridiculous that we can expect to ship multiple non-trivial features a day. Yeah, obviously that was a fairly trivial feature, but we could do something much bigger if we were going to be working for an hour or so. All right, so if we're able to produce our changes this fast, it forces us to think a little bit differently about code. We start to take a different relationship to our project. So here are some of the ways that on our team we now have a different attitude to code and to the kind of rules that we've had for our whole career going up until now. Maybe some of them don't really apply anymore. So I think we quickly start to feel that code isn't a precious asset anymore. Code is cheap. If you want to make a lot of code, you can make a lot of code very quickly. If you want to prototype something, particularly if it doesn't have to be done to a production standard, you can make it unbelievably quickly now. Prototypes are basically free. Now, there's still a big gap between that and production-ready code, but specifically when it comes to prototypes, very, very cheap, very, very fast to do. And when we start working on something and we find that it's going to require a whole bunch of non-trivial implementation, in the past we might have thought, oh, well, that's going to be a lot of time to produce it and it's going to be hard to maintain it and all that sort of thing. We don't necessarily feel that way anymore. We might just feel, all right, so I need 1,000 lines of code to parse something, so what? You know, the Opus model will produce that for me in a few minutes. And if I don't like it later, I'll throw it away. If I need to rewrite it, I'll rewrite it. If I need to change the language, if I need to change libraries, whatever, I'll just regenerate it later. The code itself is cheap. I don't need to be precious about it. And when it comes to design processes, in the past, if you were going to do like a week-long piece of feature work, you would have probably scheduled a bunch of meetings and wanted to like really build consensus for this feature before you started working on it and worked out what all the architectural concerns were going to be and anticipate the problems up front. We don't really do that anymore because what we find now is if you've got a feature that you're going to produce in a couple of hours, just do it, right? You know, the agent will spit out an implementation of something, and in fact, there might be multiple different ways of doing something. Do all three, it's fine. And then you can compare all three different ways to implement something. Learn by actually doing the work, and then seeing what the outcomes of it are, what the architectural problems actually turned out to be. And then, at the end of it, you might just throw it all away because it turns out to be a mess in some way. But if it doesn't, maybe one of those three is what you want. So it is a different way to approach the work that we do. All right, so let's get a little bit deeper into this. Let's start thinking about some of the ways that you can customize and tune what an agent is going to be doing and hopefully make yourself more successful than you would have been. Because as we go through this, we are going to find that some things are actually going to cause new challenges for us. And there are going to be a whole bunch of unknowns that we'll encounter, and we need to try and anticipate what we're getting ourselves into and what we're going to need in order to be more successful. Okay, so when it comes to coding agents, there are a lot of different features and terminologies that you might or might not be familiar with. Here are a load of words, and these words correspond to features in coding agent tools. Now, obviously, it varies a bit from one to another. Claude Code's going to have different features compared with Copilot or Gemini or Opus, or sorry, Opus is the model, or like OpenCode. They're all going to have slightly different features. And I'm not here to try and push you towards one or the other. I think all of them are going to be something that you can be successful with. I'm going to show you Copilot because I'm actually on that team, but you know, there are similar features in all of them. Right, now, I'm going to start by showing you this subagents feature in a bit more detail, but before I explain it, let me just start a demo, because it takes a minute to run in the background. So I want a large code base to start with to show you something, and so here I've got a game engine. It actually implements Doom, which I'm sure will be familiar to most people here. It's written in .NET, actually, and here's a pull request that came in a few weeks ago. And let's say that your job was to review this pull request. Well, you might look at it and say, oh, 2 files changed. That's going to be quite an easy review for me to do. I'll get that done in a minute or so. So you go in and you have a look at the changes that they've made in these 2 files, and you see, oh, you know what? This is not going to be so easy to review, actually. This is actually kind of terrifying, especially if you really want to know that every single one of these lines of code doesn't have like an off-by-1 error in it or something like that. That is going to be a non-trivial process. So what if we could get our coding agent to do the review for us? Well, maybe we can, or maybe it's just going to hallucinate some garbage. How would we know? So let's try it. I'm going to go over here to Copilot, and I'm going to spin that up, and I'm going to tell it that I want it to review this. So I'm going to say, I would like you to review the PR, paste that in in parallel across Opus, Haiku, and Gemini. Now, those three things, those are different AI models, and they're going to have slightly different takes on this code. Some of them will be stricter than others. Some of them are going to hallucinate in some way, and others might not. But by running this parallel code review across multiple agents, I can get multiple levels of feedback and compare them and try and spot what's the real information and what's not. So you can see it's fetched the pull request from GitHub. It's using its large output handling here, actually. So because models have got a limited context window, it's decided that this is too much to go in the context window, so it's saved it to a file on disk, and then each of those different agents can read different parts of those files on demand. All right, so it's got the PR content, and it's started the parallel review across these three different agents, and then it's going to have to wait for them to produce their output. All right, so while that's running, let's go back over here. Right, so subagents. That's this thing that I've just shown you here, where an agent can start multiple tasks in parallel with different context windows, different tools, different models, and so on, and combine the results and orchestrate things for you. Plan mode, I'm going to get to in a minute. I'll demonstrate that for you. That's a way that you can anticipate or work with the model to make a comprehensive plan for the work that you're going to be doing and try and avoid the case where it does the wrong thing. Skills is a relatively new enhancement. How many of you have seen or used skills so far? Yeah, a pretty small number. All right, so that's going to be worth digging into a little bit. So skills are a way that you can create reusable capabilities for coding agents and then share them across different people on your team. I'll show you an example. Delegate's a way of sending stuff up into the cloud after you've worked on it locally so that you don't have to use up your own machine. Memories, that's a way of keeping track of facts that can span your team. So if one of your colleagues tells the agent something like, oh, never use this way of writing a test, always write tests in this other way, then that memory can be stored and tracked within your project so that other coding agents will automatically pick that up. Hooks gives you deterministic callbacks, so you can change what an agent does. The other stuff is all cool too. But let's see how we're getting on with this review. I can see that Haiku, oh, actually, they've all just finished. Right, so Haiku finished first, and then it was Gemini, and then Opus. And it's now writing up this combined review across all of them. Opus has found a particular problem, and let's see. Okay, all right, so it's given us this report. Opus has found an issue. Haiku didn't find any issues. Gemini found 3 issues. I don't want to read them individually. I'm just going to tell it I want to know how they compare. So what were the main disagreements? All right, so let's see how these different reviews compare with each other and what we can learn about this. So we've got, there's something to do with element bounds.empty, where Opus says there's a bug, Haiku doesn't. All right, so what does it say? It says Opus is more rigorous, the math does overflow. The overall assessment, Opus found an issue, Haiku said there's no problems at all, and Gemini found 3 problems. All right, so this kind of lines up with my experience of these models. If you don't know, Haiku is the smallest one of these models. It responds very quickly, but it doesn't have very good deep insights. Gemini is a slightly more anxious model. It will tend to complain about a lot of things, and it will pick up on a lot of architectural concerns, even if they're not really real issues, but it's interesting to get its points of view. And Opus is sort of the big daddy of the coding agent world at the moment, and that's probably the one whose opinions I'd be most interested in. All right, so that's how we can orchestrate multiple agents quite trivially from a coding agent tool like that. All right, so let's have a go at digging a bit deeper into some of these features, and also let's just think a little bit about some of the challenges that this is going to give us right now. So I don't know about you, but back in the day when JavaScript frameworks were coming out every 3 days, I used to find that was quite hard to keep up with. When it comes to coding agents, even more so the case. Among this list of features here, probably about half of them is stuff that's all been invented in the last 3 weeks or something. That's not an exaggeration. So like trying to keep up with this is almost a full-time job in itself. And it is my full-time job, and I struggle with it. So I pity the people who don't get to spend that being their full-time job. And it's not just stuff that's shipping in the products themselves. Other people are coming up with even more complex things that you can do on top of coding agents. Here's a couple of examples. Right, so This thing called Gastown started getting a bit of traction on Hacker News recently. Steve Yegi's a well-known person in the software industry. He's created this sort of fictional world of coding agents where you've got a mayor and they've got convoys of beads which represent work, and they send them to different agents. And you know, it's this whole like fictional let's pretend world of coding agents. And does it work or not? I don't really know, but people are playing around with this sort of thing. And another one that became incredibly hot about 2 weeks ago for maybe 3 days was Ralph Wiggum, which I'm sure some of you have heard of, and some of you are probably just thinking, like, why am I here? Why did I get out of bed to have this guy going on about Ralph Wiggum? Why is that even relevant? Well, the thing is that coding agents can be really lazy, and Ralph Wiggum tries to solve that problem. So you'll tell your agent, hey, do this task. It's got 6 parts in it, and it will do it for a bit, and it'll say, I've done 4 of the 6 tasks, so I'm finished. And you say, what? No, go and do the other 2 tasks. And it says, yes, you're absolutely right. I'll do those 2 other tasks. And then a minute later, it'll go, those are quite hard, so I'll leave those for the future. And you'll say, no, do them. And it will say, OK, yes, I will. And then it'll say, I've added to-do comments to say that we'll do these in the future. And you think, oh, why am I doing this? So Ralph Wiggum tries to just force it to actually do the work. It's simply a while loop that just keeps saying do it, do it, do it, do it, over and over to the coding agent. And the idea is you leave it running overnight or whatever, and who knows how many tokens it consumes. But when you wake up in the morning, you've ported your entire operating system to Rust and created AGI. That's the idea of it. Does it work? Does it not? Why is it called Ralph Wiggum? Well, these are all mysteries. But I would encourage you to think about this stuff, but not get too caught up in it. Because this is just going to keep changing all the time. And I don't know about you, but you will probably start to experience a bit of FOMO when it comes to all of this stuff. Like, how can you know what is worth thinking about and what is not worth thinking about, given how quickly we're iterating? So to try and counteract some of this FOMO effect, I want to take it back to some fundamentals that I think are the actual gems within the pile here, that from experience of working on a coding agent team for the last 6 months, what do we think are the fundamentals that actually make a real difference to whether an agent succeeds or fails with a given task? And we're going to start with planning. And you might notice, actually, that all of these are things that are generally good for humans as well. So it kind of makes sense. Right, planning. One of the main reasons why tasks assigned to coding agents might not turn out in the way you want is that the problem might be underspecified. And agents are very lazy. If they can get away with just saying, like, oh, I did this in a sort of whatever was the easiest way, whether you wanted it or not, they'll kind of do that. So planning is a way of ensuring that you've got a full communication of what you want the agent to do up front. Let me show you that. Right. So I need another application to work on. So I've gone with literally the most mainstream business scenario I can think of, which is just standard e-commerce. Right. So I've got this open source .NET e-commerce platform here, totally normal. The only unusual things are the insane prices in the test data and the fact that the languages seem all messed up. But apart from that, it's just normal e-commerce. All right. Now let's say I want to add a non-trivial feature into this application right now. So I could go into my coding agent here within that repo. Let's start up Copilot. And I could tell it to start work, OK? But how do I tell it exactly what to do? You'll notice down here that we've got this Shift and Tab to cycle mode thing. And I can do that to switch myself into plan mode. And while I'm in plan mode there, it knows that whatever I tell it to do, I don't really want it to start implementing it. I want it to work with me on working out a plan. All right, so let's tell it a complicated feature to work on. Add a product customization feature. OK, now that is potentially an enormous piece of work for it to do. Now, what does that even mean, product customization? So it's going to start thinking about it. It's going to research our product code, hopefully. Yeah, so it's listing the files. It's using that explore subagent again to explore the architecture. And it's thinking about this project and what that might mean. Oh, it says product customization is ambiguous. I need to clarify what the user means. So how is it going to do that? Okay, so it brings up a multiple choice option for us. And we can type in an arbitrary answer if we want to. But let's say I'm just going to pick that I want the build your own product option here. So let's put that in. And it's going to think a little bit more. Maybe it's ready to write a plan now. Maybe it's not. Okay, it says, what's the use case for build your own? I'm just going to go with custom PC builder. All right. Maybe it's ready to start now. I don't know. Let's see. All right. Should the system enforce compatibility? Okay. I don't want to think about this anymore. This is a demo, right? So I don't need it to be a complete thing. So I'm just going to tell it, no more questions now. And it will now have to get started working on that. All right. So it's going to think about this feature, and hopefully it will come up with a plan about how to actually do it. All right. So let's just wait for a moment while it contemplates that. Create implementation plan. It's listing files, it's grepping for stuff. I have enough information to create a comprehensive plan. Let me create the plan file. Go on then. Okay, so it's created this file, and you can see this gone into a sort of temporary directory rather than my actual project, because it might just be an ephemeral plan. We can move it into the project later if we want to, but it's done that in the background, and it says you can press Control-Y to actually read the whole thing, so I'll do that, and then hopefully that will be in my IDE. Okay, over here. All right, so here's what it's just come up with. Problem statement, add a build your own feature. Here's my proposed approach. Here are some entities that we'll add. Here's the work plan, split up into multiple phases. Here's the technical architecture, stuff we'll add, database stuff, open questions, and so on. Now, this is a really important document if you're working on a big feature like that. And if I was doing this for real, I would spend a long time working on this document. I would easily spend a full hour just working with the agent on refining this plan and actually breaking down each of these pieces of work, checking that I understand what the architecture is going to be like, anticipating any problems, telling it about other stuff, and so on. And it can update this plan for us automatically, or you can just literally edit the file yourself if you want to. In this case, I'm just going to add something that I often add to these things. For each phase, add a validation line to the bottom saying what I'm going to be able to see in the UI to check it works. Okay, so this is a tip that I would give you. Often it's really helpful for your coding agent not to just produce code, but to structure its work in such a way that at each stage there's something that you as a human can objectively observe in the UI to make sure that it's actually doing something useful. You don't want it to just produce code and it compiles, great, but how do you know it's the right code? You want to see it do something. All right, so you can see it's doing a bunch of further edits to that plan document. It's now added like this validation step, and it will keep on adding more validation steps. And then while it's actually working on this task, it will keep the plan up to date. So if it learns new things, it will add them into the plan, and it will mark off the tasks as done as it does them. And that will allow you to keep track of its work, and it also allows it to keep track of its work over a long time horizon. Okay, so that's the first one of these big techniques. Next one I want to talk about is composition. All right? So when you, as a human, are taking on some difficult task, you don't learn it from scratch every single time. You bring your skills and your tools that you already know about from the past that you can apply, and that allows you to work much faster. And the same thing can be true with coding agents as well. And skills are a way of defining certain abilities that an agent can have that you can then keep track of and share across people on your team or even across the whole industry if you want to. So let me show you how you can get skills, how you can create skills, and how you can use them. So the first way you can get skills is by installing skills that other people have already published onto the internet. So let me give you an example of that. So I'm going to go back over here, and in a new session, I'm going to first list the skills that I've got installed. And you can see that I've just got one skill initially. Now forget about this. This is going to be part of a demo that I do in a few minutes. So pretend that you didn't see it and that there's just no skills installed right now. And I'll show you how we can install skills that someone else has made. All right, so the first way that we can do it is that we can get them from something that's called a marketplace, which is basically just another word for a Git repo that contains skills. All right, so this is a Git repo, Anthropic/skills. And if I go over here in my browser to it, that's this one here, then you'll see that this kindly provided by Anthropic is a collection of skills that you can plug into your coding agent. And we've got things like MCP builders, PDFs, PowerPoint, stuff to do with themes and other stuff. All right, so we can dig into what each of these are, but let's just have a go at installing this collection of skills firstly. All right, so we need to just paste in a command because it's too hard for me to remember. So what is it that I need? It's this. So plugin install document skills, blah, blah, blah. All right. And so that's installed this document skills plugin. And now if I list my skills, you can see I've got loads of them. And they correspond to stuff that we saw on that repo a minute ago. Now, what even are skills really? What are they mechanically? Well, you'll see that when I create one in a minute. But another way to look at it is by going to this website that gives you the spec for it. And it shows you that a skill is basically, at root, just a markdown file. It's a markdown file with a bit of metadata in it. If we can see an example of one, here's PDF processing. It's got a name, it's got a description, and then it's got loads of information about how to do it. And this might be a really long document. So the clever thing about skills is the way they are progressively disclosed to the model. Models have got a limited context window, and if you had 1,000 skills and each of them had got a massive document associated with it, you would not want to load all that into context up front. It would just confuse the model and make it perform badly. So the great thing about skills is it only has to load this description into context up front, and that's just enough for the model to realize when it needs to use a particular skill, and when it realizes that, it can research it and get the full information. And it's not just markdown content, it can be tools and scripts and things like that as well, as I'll show you. So, best way to understand this, probably, is to create our own skill right now. So let's say you want to make the ability to share across your team for coding agents to check on your product's build status. All right, so I'm going to do that now. I am going to firstly show you that we just installed this skill creator skill. So easiest way to create a skill, use the skill creator skill. All right, so let's say use skill creator skill to create a skill in, and that location, it should ask user which project, and we'll do .NET, ASP.NET Core, or GitHub Copilot SDK, and get build status for it. Right, so that's going to, it needs to know to use the skill creator skill, right? So it doesn't know that initially. It's going to realize that this task corresponds to skill creator, and it's going to load that into its context. And once it's done that, it's going to do a bit of research and find out how exactly you're supposed to create skills, and then hopefully it will actually do that. It's running a Python script that is like a project template for skills. And if we go over here, I should be able to show you it actually creating that. So it's going to appear in here, and it's an empty file right now, okay? So it's checking what it's doing. What's it doing? The file is empty, yes. Oh, okay, it's done it now, right? So it's added this build status skill here with this description, and it's got a workflow that corresponds to what I just told it, which is ask the user which project, and then check. Now, obviously, I can edit this file directly if I want to change how the skill works, but I can also just instruct the agent to update it as well. So let's say I only want it to get build status from the main branch. So let's say actually only get status from main, okay? So it's going to figure out how to do that, and it's going to make some edits to this, hopefully. So I think, okay, yeah, it's done it. It's just added this branch main thing onto the skill right now. Okay, so now that's something that both I and other people on my team would be able to use because this will be stored in source control in my project. All right, so let's have a go at actually using it, shall we? So I'll go into a new session and check that we've got it installed. And you see that we do by default because it's in the project there, build status. And now I can use that. Notice also that it shows up as a slash command. So we can autocomplete on the name of that skill as well now to invoke it really quickly. So let's submit that. It's going to think about it. Obviously, it knows that we want it to use the build status skill there because we've used the slash command. It's going to load that into context, and it's going to ask us, all right, what project do you want to check status for? Let's do Copilot SDK. And it's going to invoke that skill now. So it's going to follow whatever instructions are specified in there and merge that in with whatever other tasks it's doing. What is it doing? Okay, so it's used GitHub Actions to fetch the build status, and then it's parsing that, and it's producing this happy wall of green text. So good, it works, and that's something that you could easily start reusing amongst other people on your team. All right. Great, so we're making good progress here on how to guide an agent to be productive in our scenarios. Let's take on this last one now. I think this is probably the most important one of them all. So another really annoying anti-pattern that coding agents can get into is you tell it to implement something, and it goes, yay, I did it, I implemented it, and you go and check it, and it doesn't work. So you go back and you say, it doesn't work. And it says, oh, I'm really sorry, I'll fix that for you. And it does some change, and it says, I've done it now. And you try it, and it still doesn't work. And it's just really annoying being in that cycle. But you can break out of that cycle by giving a feedback loop to the agent, so it can check its own work as it goes. And that can be done at multiple levels. So at the simplest level, make sure it's able to actually compile your code, because then if there's any build errors, it can see them and address them itself. If you've got linters, if you've got a test suite, again, make sure it's able to actually run them itself so that it can detect any problems. But the biggest power move, I think, of all, is to give it the ability to actually run your real application and interact with it like an end user, because that way it can do what you would do as a developer. When you implement something, you actually try it in your application, right? Why can't the agent do that? Well, it can if you give it a skill to do so. So to demonstrate that, I am going to go back to this simple commerce thing again, and imagine I want to add some other feature into that. And I'm going to do so using a skill that I prepared earlier, because it takes too long to create this. So I've got this simple commerce automation skill. I used the skill creator to create it, obviously. It took me about half an hour or something. And I've taught it how to automate a browser using Playwright so it can interact with my application. And I'm giving it lots of info that's specific to my app, like here's the standard admin credentials for our test data. Here's how to set the site up in the first place. Here's how to start a browser. You don't have to work it out. I've provided some actual scripts for you that do that. I've got all these other little JavaScript snippets that teach you how to explore and list links that are on pages and navigate around, register users, and all kinds of stuff like that. And you can build up more and more capabilities over time. So let's try using it, shall we? Right, I'm going to get out of here, and I'm going to start a new session. And then in here, I am going to go to my list of skills, and you can see that I've got this simple commerce automation skill in there. All right, so let's use that to start a browser. All right, so hopefully it will discover that it needs to bring that skill into its context window, and it does, and then it should be able to use it. So it's using a script that's provided in there, and you can see a real browser has just popped up here. All right, that's good. Now, based on all of that knowledge, I can tell it to do other things with it as well. So let's say, for example, I would like it to use that skill to register a new user, Steve. All right, and because there's a built-in script for doing that, it should be able to do this quite reliably. So it discovers which script to use, and it goes through that process. It was pretty quick, but you can see it's registered this user and logged in as that right now. Okay? And I could use this to make it do more complicated things as well. So let's say that I wanted to work on some sort of order management thing, and I need some test data, or I want it to be able to check that order management actually works. I could say to it something like, use that skill again, and as admin, create a new product. Let's call that the Super Headphones, and then place 5 orders for it as Steve, 5 separate orders, actually. Okay, so that's a fairly non-trivial flow that it's going to have to go through, but it should be able to do it because our skill tells it all about how to explore the site, how to log in as admin and things like that. So it's generated a script, it's logged in as admin, it's gone to the product creation wizard, it's going through that flow, it's created Super Headphones, it's logged in as Steve again, and it's now starting to place orders as Steve. All right, so clearly that is useful if you just want to automate stuff for testing purposes. But the bigger point that I'm trying to make with this is that you really want the agent to be able to do this itself because it chooses to. You want it to have that power whenever it implements something to go, now I'm actually going to check this works. Let me pop open a browser and click through the flow and make sure that this feature is really implemented properly. And if there's any errors that come up, it can see those errors and it can go back to the code and start making changes to it. Okay, so that's some of the fundamentals that I want to get to. All right, so far, everything's been great. We've been moving forwards rapidly. We're just more productive. We're happier. Nothing could go wrong, right? Well, I would say that this is great, but there are some real drawbacks that we want to start thinking about as developers as well. And there are some difficult, hard questions that are probably even beyond the scope of what we can get to. But just at a simple level, one of the biggest challenges that I see around me right now on the team I'm on is just the sheer rate at which we're producing code. So here's a snapshot of our list of pull requests from a couple of days ago. And this was just the first 2 hours of the day. So we've had 6 new PRs come in, 5 of which are waiting for reviews. And this is while just the Europeans are online. So there's only 3 of us in Europe. The rest of the team's all in the US. They're asleep right now. And we've already got 6 PRs out, and we're waiting for each other to review them. How are we going to manage this? Like, this sheer rate at which code is being created, who's going to read it? How do we know that it's actually correct? Like, I don't think that this is a solved problem. I'm not here to say the answer is this, because we don't know the answer right now. This is something we're working at. Obviously, we're thinking, can we throw more AI at this problem? But we don't know, right? It's an unsolved problem right now. It's a challenge for us. And another challenge that I want to bring up, and I don't know if you'll relate to this or not, but it's something that bothers me a little bit, is when I go back into my IDE and I start trying to write code with my actual fingers like an animal, it's a weird experience to me now. Like, I'm not sure what buttons to press, and I just like look at my hands and think like, make the code come out of them somehow, and I'm not sure how to do it. Because I guess genuinely my like muscle memory is starting to change in some way, and I feel like when I want a load of code to come up on the screen, I should say it in English. It feels weird to me to type it out now. And I'm not proud of that. I don't think that's necessarily a great thing. I don't know what to do. Like, is it a problem or not? Do I need to do some like daily manual coding exercises to keep myself sharp or something, or is there no point? I honestly don't know, but I'm very interested to hear what the rest of you think about that sort of thing. And obviously there are deeper questions still, like, you know, where are we really going in the long term as an industry with this? What difference is it going to make to our like role in the world, the supply and demand of software engineers, that sort of thing? We don't have the answers to these things right now. I don't feel qualified to predict the future, so I'm not going to. But I would love to chat with any of you about this and see what sort of things you are thinking about this. But despite all of these unknowns, I don't think that I'd be willing to let anyone take this away from me now. Like, the sheer sense of productivity that I get is not something I'm going to give up on. I do feel that I can do stuff that I wouldn't do before. So, quick example of this. Last week, I was using some screen recording software, and it was crashing. It's open source, so I went to the GitHub repo, and I wanted to see if other people reported this issue. Is there some sort of workaround? And other people had reported it, but there was no workaround. This thing was written in Rust. I don't speak Rust, so normally I would not have been able to do anything about that. But I thought, oh, let's just see what happens if I just get Copilot on this. So, you know, I told Copilot, go to this repo, clone it, investigate the following issue. If you can find a fix, submit a pull request. And that's it. I didn't tell it how to clone it, how to submit a pull request, any of that stuff. And genuinely, in under 10 minutes, it did track it down. It said, you know, there's a UTF-8 parsing bug here. Here's a 3-line fix for it. I've submitted a PR for you. And the PR was merged the following day. And that's not something that I would have attempted in the past. Like, maybe if I really wanted to, I could maybe have done that. But like, the overhead of dealing with the fact that it was written in Rust would probably have meant I wouldn't have attempted it. But I am now empowered to do that sort of thing. So that does feel good to me, despite all the uncertainty. Now, everything we've talked about so far is about making you, as a developer, have additional powers. And that's great, but there are other people in the world besides software developers. And maybe you might want to bring some of these kind of powers to your users as well. And obviously, it's been possible for several years to use AI within your application. But a relatively new thing is being able to use the actual agent loops that come from coding agents within your application as well, which brings a lot of built-in smartness that's pre-optimized. So, something that we just shipped in the last couple of weeks is an SDK for Copilot. It's available for Node, Python, .NET, and Go, and there are community projects for other languages as well. And this allows you to use the same agentic harness that powers Copilot CLI, but within your application for other features. And it brings all the tools and prompts and all the optimization that we've done. So you get something that's very smart out of the box. Let me show you a quick example of doing something with that. And I'm going to start with another software-related thing, just so it's more relatable, but I'll show you it's not limited to that in a minute. So over here, I've got a .NET project called Issue Sizer, which doesn't have much implementation in it right now. And I am going to implement something that can estimate how difficult a particular issue is going to be to solve. And it's going to use all the smartness of the Copilot coding agent, but I'll be able to control it from my own code. Right, so let's start by adding an instance of Copilot client. And that's just going to use whatever thing I've got installed locally with whatever credentials I'm logged in as, but you can customize that if you pass options. All right, and it's going to create a new session, and then I'll show you incredibly trivially, we can just make it list the files in this directory. Now, I don't have to give it any special tools to be able to access the file system or whatever, because it's using the real coding agent to do this, and obviously that's already got the ability to see files around it and make decisions about how to investigate them. Now, it's going to take a moment to run the first time. It always does. And we're not going to see any output until it finishes, but I'll solve that in a second. All right, you can see it was running inside the build output directory there, and so it's seeing an executable and a bunch of DLLs and other stuff. Okay, so that's fine. But let's get a little bit more information about what it's doing. And one way that I can do that is I can subscribe to some events. So we've got this on callback, and it will give us an event info. And we've got about 20 different types of events. They've all got nice, strongly typed types to represent them. And I'm going to detect if it's a tool, and I'll display the tool name. And if not, I'll just display the event name in general. So if I run that again now, we should see a little bit more information as it goes. We can see we've modified the messages. There's a user message. The assistant has started some work. The assistant's done some reasoning. It's listed its intent as listed directory contents. And then it's doing a view call to find the files at that location. All right, that's fine. So we can see a bit more information, and we could build a UI that updates in a slightly more dynamic way to show what the agent's doing if we want to. All right? But so far, that's just using the built-in tools for the coding agent. You can, of course, add your own tools and capabilities to it as well. Since this is a C# application, I'll do it using C#. So I'm going to define a new method here called getIssueSizeLabel, just to show that we can. It's going to take in a number of days' work, and based on that, it will use this absolutely outrageous syntax, what on earth is that, to return a different string depending on what number comes in. All right, let's put a breakpoint so we can see that. And then I'm going to have to make that available in my session. So here I'm going to pass a set of tools. I'm using the Microsoft Extensions AI library to turn that method into something that AI can call. And once I've done that, I'm just going to prompt it to actually use that. So I'm going to say, what's the label for an issue that takes 6 days? And if I run that with the debugger now, and then hopefully it will have access to that tool, and it will choose to call it in order to satisfy this particular request. All right, so you can see it's invoked my method. It's passed in 6 as the number of days of work. And then when it gets the string that comes back, it says the label is size M. All right, great, so it works. Cool. Now let's use this to implement something that actually estimates the size of a piece of work. And it might seem like that would be a hard problem to solve, but it's not really, because coding agents have pretty much got that capability already. So I could add a nice big prompt like this that says, you're a software engineer, estimate the complexity of the issue, check if the issue corresponds to source in the current directory, and if so, investigate the code to provide a more accurate estimate. And it will use all the capabilities like the explore subagent or whatever else in order to do that. Okay, and it's going to take this issue URL. So let's run that. And it says, enter your issue URL. Let's find an issue that we can do. Let's go to the Copilot SDK repo, go into the list of issues, find something in there that looks quite big. All right, this one's quite big. Connect to active CLI sessions. Okay, so if I go back over here and paste that in, then it should use all of the capabilities that the coding agent already has by default. So it's got the ability to, like fetch stuff from the web and deal with if it's a large output and inspect that content. It's able to look at the files on disk, and it can sort of reason about whether this is the code corresponding to that repo, which it isn't. So in this case, it's just going to skip ahead to giving an estimate in general, and it's decided that it's a medium-sized issue, which is probably reasonable, 5 days of work. All right, cool. So that's how you could control one of these coding agents from within your application and build upon all the skills and capabilities that are already available to it. But it's not limited to just software engineering type tasks. So to demonstrate that, we've also created this other little demo that I'll be able to bring up over here. All right. So up here in the top right of PowerPoint, you see I've added this little extension here, GitHub Copilot. Now, I just want to be clear, this is not a feature that we're actually shipping. This is not a product announcement or whatever. This is just a fun little demo that we put together where we've used the SDK that I showed you there to create a sidebar where I can type in some instruction and it will use coding agent features, but it's also plugged into the Office APIs so it can interact with the document itself. So I could say something like, make a 5-slide presentation. I know the text is too small. Let's zoom in. Make a 5-slide presentation about NDC London, use cool layouts and lots of London puns. All right, so I'm using Haiku here, which is a small model. I'm using that just because it's fast. I find in practice the layouts it produces are a bit of a mess, so it might be ugly. If I used something like Opus, it would generally produce really quite good designs, but it does take like a whole minute to respond, and I don't want you to have to wait for that. So it's working, and hopefully it's going to come up with an actual answer for us in a minute, which is unusually slow right now. Let's just going to start a new instance of that, just in case I can make this go faster. Okay, so I'm trying that again. And hopefully we will get some output from that. Okay, so it's adding a slide. Code on the Thames, where code meets culture. All right, let's see what else it comes up with. What is NDC London? The most prestigious constants. It's not a London fog of confusion. All right. Cool, fine, conference highlights, great. All right, so as you can see, it is working. The puns are not great. I think we need some slightly more advanced AI if we want. What on earth is that? We're not pulling your big, what? I don't, okay. Let's move away from that quickly, right? All right. I'm deeply sorry, I do apologize. That's one of the worst things I've ever done. All right. All right, point is, you could apply the intelligence of a coding agent to tasks that might not just be coding using an SDK like this. All right, so I think we're coming up to being done, and I'm sure many of you are very, very keen to get out there and get some coffee. So I just want to leave you with some thoughts about what this means for us in our industry right now. What are we anymore? Like, what are we trying to become? I think at the end of it, it does not change the fact that we're still engineers. It gives us additional tools, additional powers, and allows us to apply our talents to a wider range of things. But fundamentally, we are still doing the same job, right? We're still using our brains to make decisions about how to solve problems. There's still an almost infinite space of possibilities for what you can actually build, and it's up to you to apply your decisions of taste and your decisions of wisdom to what you're actually going to use this more powerful tooling to achieve. And hopefully, it will allow you to take on problems that you wouldn't have done before. So that's my challenge to you. Get one of these CLI tools, I don't care which one it is, and try doing something that you wouldn't have done before. If you want to try fixing a bug in some code that you don't even speak the language of, try that. If you want to try implementing a prototype for something in your work, do it. If you want to try that really difficult feature that people have been saying for a year can't be done because it's too hard, just see what happens if you just throw the problem at your coding agent. I don't know if it's going to work, but you will learn something. And I would say that for a lot of these prototyping things, you're going to be pretty delighted with what you can get in an hour or two's work. All right, so going to leave you with that. I hope you have a really good last day of the conference. If you're around, I would love to chat to you about any of this stuff. But other than that, just have a really good day and yeah, enjoy your time.